Hey there and welcome. Today we're going to crack open the world of triangles and find a secret code that's hidden inside every single one. It's called trigonometry. And trust me, by the time we're done, you are never going to look at a simple triangle the same way again.
I want you to think about this for a second. What if you could figure out the height of a massive building without ever leaving the ground? Or the distance across a river? Sounds like magic, right? Well, it's not, it's math. And that's the exact puzzle we are going to solve together today.
All right, so here's our game plan. First, we'll find the key to this whole thing, the right-angled triangle. Then we'll learn the 3 secret words of its language, what we call the core ratios. After that, I'll show you some magic numbers that act as awesome shortcuts. And finally, we'll take all this new knowledge and put it to work solving some really cool problems. You ready? Let's do it! So, our entire adventure, everything we're about to learn, it all starts with one simple, super important shape. It is the absolute hero of our story, the right-angled triangle. Okay, let's break it down. Every right-angled triangle has, 3 sides and 3 angles. We usually label the angles with capital letters, A, B, and C, and the sides opposite them get the same letter but lowercase. Now, that side across from the 90-degree angle, that's the big one. It's always the longest, and it has a special name, the hypotenuse. The other 2 sides get their names based on which angle we're looking from. One is opposite the angle, and the other one is right next to it or adjacent. Getting this perspective down is the absolute first step to unlocking this whole thing. Now for the secret code itself. It's actually made up of 3 fundamental relationships. Think of them as these unbreakable rules that perfectly connect an angle's size to the lengths of the triangle's sides. So let's meet our 3 key players. First up, we've got sin, which we just write as sin. For any angle you pick, its sign is just a simple fraction, the length of the side opposite it, divided by the length of the hypotenuse. So, for our angle A, that's height over hypotenuse, or A divided by B. Simple as that. Next up is cosine, or cos. This time, it's the ratio of the side adjacent to our angle, the base, to the hypotenuse. So, again, from angle A's point of view, that's the side right next to it, C, divided by that long hypotenuse, B. And our third and final ratio is tangent, or tan. This one's a little different because it only deals with the 2 shorter sides. It's the opposite side divided by the adjacent side, so height over base, or A over C. And there you have it. That's the secret. Sine, cosine, and tangent are just these predictable fractions that tell you everything about a triangle's proportions. Okay, hang on. This is super important. This is the part that trips a lot of people up. Those words, height and base, or opposite and adjacent, they aren't permanent labels. It all depends on which angle you're looking from. If we switched over to angle C, the sides we called height and base would completely swap roles. So you always have to ask yourself, okay, from this angle, which side is opposite me and which one is right next to me? So these ratios work for any angle, which is awesome. But there are a few special angles that show up all the time in math and science. And the ratios are so common that they're worth knowing by heart. Think of them as magic numbers or universal keys that give us some really powerful shortcuts. So our first special triangle is what you get when you slice a perfect square right in half, diagonally. What's left is a right-angled triangle with 2 45-degree angles. And because it came from a square, its 2 shorter sides, the legs, are exactly the same length. If we say they're both length 1, then the hypotenuse is always going to be the square root of 2, every single time. Our second special triangle comes from an equilateral triangle. One where all the sides are equal. If you just drop a line straight down the middle, you split it into 2 identical right-angled triangles. And these have angles of 30, 60, and 90 degrees. This gives us another beautiful fixed ratio of side lengths. 1, the square root of 3, and 2. So, using just those 2 special triangles, we get this really neat table of values. And check out the patterns here. This is cool. As the angle A gets bigger, see how it goes from 30 to 60 degrees? Notice that the sine value gets bigger too, and so does the tangent. But look at cosine. It does the exact opposite. It gets smaller. These relationships aren't random. They're totally connected. So what about the extremes? What happens at 0 degrees or 90 degrees? Well, at 0 degrees, the triangle is basically squashed flat. It has no height, so its sine is just 0, and its cosine is 1. At 90 degrees, it's basically a straight vertical line. The height and the hypotenuse are the same length, so the sine is 1. And the base has shrunk to nothing, making the cosine 0. And that also means you can't have a tangent of 90 degrees because you can't divide by 0.
Okay, theory is great, but what's the point of all this? Well, now we get to the really fun part. Using these ratios to find missing information. Just like we talked about at the very beginning. Let's put this stuff to work. You know, the process is pretty much the same every time, kind of like a recipe. Step 1, figure out what you already know, maybe an angle and a side. Step 2, identify what you need to find. Step 3 is the key. Look at your 3 ratios, sine, cosine, tangent, and pick the one that connects what you know to what you don't know. Step 4, write out the equation, and step 5 is just a little bit of algebra to find your answer. It's totally systematic.
But wait, there's more. We can go even further. We all learned the classic formula for a triangle's area, right? 1/2 base times height. But what if you don't know the height? Well, trigonometry gives us an amazing, powerful new tool to find the area of any triangle, as long as you know 2 sides and the angle squished between them.
And the formula itself is it's so elegant. For any triangle out there, the area is just 1/2 times the length of side 1 times the length of side 2 times the sine of the angle that's trapped between them. And if that angle happens to be obtuse, bigger than 90 degrees, no problem. You just use the sine of 180 minus that angle. It's just a tiny tweak to a formula that works for everything. Let's actually try it. Imagine a triangle. It's got sides that are 10 and 6, and the angle between them is 60 degrees. Okay, so we plug it into the formula. Area equals 1/2 times 10 times 6 times the sine of 60 degrees. Now, we already know from our special angles that the sine of 60 is the square root of 3 over 2. So you multiply all that out, and what do you get? 15 times the square root of 3. Boom! We found the exact area, and we never even had to know the triangle's height. How cool is that? All right, so let's do a quick recap of everything we've unlocked. We've got our 3 core ratios, sine, cosine, and tangent, that link angles and sides together. The big thing to remember is that words like height and base all depend on your point of view. We found some magic angles, 30, 45, and 60 degrees, that have fixed values you can always rely on. And finally, we saw how you can use all of this stuff to find missing lengths and even calculate area in a whole new way. It's pretty amazing. It all starts with a really simple shape, but it gives us this incredible system for measuring and understanding the world. It really makes you wonder, doesn't it? If a secret code this elegant and powerful is hiding inside every single triangle, what other beautiful hidden rules are just waiting out there for us to find? Thanks so much for watching.